Hey guys, so we are going to finish up our packet on molarity and making those calculations. You watched an introductory video where you found the definition, and it is the concentration of the number of moles of solute, that's what you put in, per liter of solvent, and that's what's doing the dissolving, and usually in this case it's water. Our formula is capital M equals moles over liter, and the capital M is molarity. MOL is moles, and L is liters. Now, many times when solutions are measured, they're measured in milliliters. If that's the case, you have to convert to liters. Notice our formula has liters. So remember that 1 liter equals 1,000 milliliters. So if you are given milliliters and you need to convert to liters, then you have to divide by 1,000. Divide by 1,000 to convert milliliters to liters. And then that way you'll have everything in the correct unit. Okay, so let's start out working a problem here. So we have 4.67 moles of lithium sulfate dissolved to make 2.04 liters of solution. So here's our formula. So we are looking for the molarity. So molarity equals moles over liter. So here's our moles, 4.67. Here is our liters, 2.04. And we divide and we get 2.29 for a molarity. That means the concentration is 2.29 moles for every 1 liter. All right, let's do another one. I have 0.629 moles of aluminum oxide, and it makes 1,500 milliliters of solution. So notice this is milliliters, so in order to work this problem, these milliliters need to be in the unit of liters. So remember, we're going to divide by 1,000. So we divide by 1,000. This now becomes 1.5 liters. And now we have all of the information we need. So molarity equals our moles, 0.629 over liters, which is 1.5. And we divide that and we get 0.42. 0.42 moles per liter. That's the molarity. All right, let's look at C. We have 4.783 grams of sodium carbonate to make 10 liters of solution. Well, grams. There is no grams in our formula. So in order to do this, we have to make another conversion. We're going to take our grams and we're going to convert them to moles first. So we have 4.783 grams, and we're going to convert that to moles. So you know that 1 mole of sodium carbonate, now we're going to go look at the periodic table. I'll go ahead and tell you the molar mass for sodium carbonate is about 106 grams. So we're going to convert our grams to moles, and we get 0.045 moles of sodium carbonate. Now we have our moles, we can plug it into the formula. So molarity equals 0.045 moles over, and we're given 10.00 liters, so we divide and we get 0.0045 for our molarity. So just make sure you're paying attention to units. All right, so now let's use the same formula, but this time we're going to solve for the number of moles. So we're solving for that numerator. So here again, I'm going to go ahead and write the formula. So I'm given 5 liters of a 2 molar copper 2 nitrate solution. I don't know why that's dark now. There we go. And so I can fill in. So I've got 2 is my molarity. I don't know moles, that's what I'm trying to solve. And I know my liters is 5.00. So I'm going to do some algebra. This is just cross multiplication across the equal sign. Some students like to put this over 1 as a placeholder. So 1 times mole, so mole equals, and then we're going to cross multiply this way. 2 times 5 is 10. So we have 10 moles. All right, let's look at the next one. We have 3 liters of a 0.500 molar magnesium carbonate solution. So again, whoops, we're going to write our formula here. So I know that my molarity is 0.500. That's given to me. I'm solving for moles, so I don't know that, but I know my liters, 3.00. So again, some students like to put a placeholder there. I'm going to cross multiply. So I have moles equals 0.5 times 3. When I multiply that, 0.5 times 3, I get 1.5 moles. All right, let's do another one in this section. I'm given 6,200 milliliters of a 3.76 molar sodium oxide solution. All right, notice this is milliliters. Remember, we can't have milliliters, we have to have liters. So remember, to do that, we must divide by 1,000 to convert milliliters to liters. So when we divide by 1,000, we end up with 6.2 liters. So I'm going to put that right there, 6.2 liters. Now I have all the information I need to plug in my formula. So my molarity, molar says that's molarity. I have 3.76 equals, I'm solving for moles, and my volume is 6.2. You can put that over 1 as a placeholder. So moles equals 3.76 times 6.2, and I get 23.3 moles. Okay, then we have one more section to go. All right, this is trying to find, this section we're finding volume. So we're solving for L, we're solving for liters. So I have 4.67 moles of lithium sulfite dissolved to make 3.89 moles, or the molarity solution, molar solution. So I like to rewrite the formula here. So I know my molarity, 3.89. I know the moles, 4.67, but I don't know the liters. All right. So again, having that placeholder is very, very helpful here. So when I cross multiply, I get 4.67 equals 3.89 times L. 3.89 times L. L is our variable that we're solving for. So we need to divide both sides by 3.89 in order to cancel that out. And we end up with 1.2 liters. 1.2 liters. All right, let's look at B. I have 4.907 moles of aluminum oxide needed to make 0.500 of a molar solution. That's my molarity, how concentrated it is. So again, I'm looking for volume. So I have my formula. I have a molarity of 0.5. I know my moles, 4.907, but I don't know my liters. All right, I'm going to put that over 1 as a placeholder. So we have 4.907 equals 0.5 times L. And I divide both sides by 0.5 so that those will cancel out. And I end up with 9.81 liters. right, let's do one more practice problem here. Notice I'm given 78.6 grams of potassium chloride to make 1.9 molar solution. All right, I'm given the molar mass here of this this compound because I've got to convert my grams to moles. So I have 78.6 grams, and I know that 1 mole of potassium chloride is 74.55 grams, because that's given to me right there. So I'm going to divide 78.6 divided by 74.55, and I get 1.05. 1.05 moles. Alright, so now I'm ready to plug in. So if I know my molarity is 1.9, I know I've got 1.05 moles, and I don't know my liters. Put that over 1. So now I have 1.05 equals 1.90 times L. So that cancels out. So I have 1.05 divided by 1.9, and that gives me 0.55. 0.55 liters. And that's it for molarity. You'll notice that down here at the bottom, dilutions is marked out. We're not going to be doing dilution calculations. You are going to be doing some practice problems on the next page. I've listed this on its learning on the directions. You'll be doing number 1, 3, 4, 5, and 6, and 8. All right, and those are listed on its learning, and the key for these problems will be on its learning. So practice first, and then check your key.